Okay, so we're going to start learning about functions in Python. This is some of the information you will need to complete the first homework assignment. Okay, so what is a function? A function is a block of code that only runs when it is called. In some languages, this is called a subroutine, but it doesn't really matter. Functions always have some kind of input data, although that can be none, and also a return value, which can also be none. Okay, although most languages allow only one return value, in Python we do have ways of returning multiple values, which is an interesting and unique feature. Anytime you see a keyword followed by open and close parentheses, you're calling a function. So we've actually already used a bunch of functions. We've done print, we've done input, and we've done these typecasting functions already. So here's a very simple function. Okay, it's a little bit of a trick question the way it's stated here, but let's talk about it a little bit. Okay, so there's a function called convert. It takes one parameter or argument. Those words are used interchangeably. Temperature. It does some mathematical calculation with this temperature, and it returns the result of that mathematical calculation back to the calling program. Okay, so we're going to walk this through in very minute detail in a little bit, but for right now, let's think about this as a temperature, some conversion. Okay, so the way this works in the program is when a function is defined, okay, that code is skipped over in the running of a Python program. Okay, and just the definition happens. Okay, when it hits this command, it will actually run this function. The 29 will be passed into the temperature. So it'll take the temperature, it will convert it to Fahrenheit, as it turns out. This is the Fahrenheit or the Celsius to Fahrenheit conversion. Okay, do this calculation following the order of operations we talked about last time. Okay, and return the value back. So I don't know what the answer to this is. It's not a very pretty number. And that response will actually be replaced in this, wherever this placeholder was. Okay, so in this case, the answer would actually be lost. So, because I'm not storing it in a variable anywhere. So if I wanted this answer to be saved, I would need to store it in a variable at the end of the operation. Okay, similarly, I would call the function again with the completely different value. You can almost think of it as another copy of the function, okay, that will run through, same thing. Again, this value will be lost if I don't save it off somewhere. Okay, so here's a better version of the function. Okay, so now I have a description, so I can say what it is. I'm converting Celsius to Fahrenheit. The parameter is the temperature in Celsius. The return type is the temperature in Fahrenheit, and there are no side effects. We'll talk about side effects later. Okay, so same exact function, just with some documentation so that somebody can easily see what's happening. Here's an even better version. Okay, so now I have a function name that is much easier to understand. My parameter name is also very clear. Okay, and now even without the documentation, it's pretty obvious what's going on in the function. But you should use the documentation version. Okay, so in the next couple of slides, we're going to see how we should structure our Python programs. Okay, Python doesn't by default, I'm just fixing up these quotes here, by default doesn't require a main like C or Fortran or C or Java do. Okay, so However, we can use a main type of program, okay, which will say that, only execute the stuff inside this if statement if you're running this from the command prompt. Okay. Then it asks the user for a temperature, and then it converts that temperature to Fahrenheit and prints out the result. So a lot going on here. We're going to break this down literally line by line. Okay. Since we have portions of our code that are not executed automatically, remember the def only executes when the function is called. Okay, so we can use something like this command to tell our program where to start. Okay, this makes it a little easier for others to understand our program. It makes it easier for us to organize our program. And overall, it's just a good idea for many reasons to understand what's going on. Okay, so once we're inside the if statement, okay, again, we're going to work from the inside out, parentheses wise. So the first thing we're going to do is call this input function, which results in a command prompt being printed to the terminal, and the user is allowed to enter a value. Okay, so let's assume that the user enters 15.9. Okay, the next thing that happens is float is called. Okay, again, I'm just working my way out in the parentheses. Okay, to convert that string, because input always returns a string. Float is called to convert that string to a decimal number. Finally, that number is saved in this variable called input temp. Okay, so again, evaluating everything on the right and then storing the result in what's on the left, using equals as our assignment operator. Okay, so once I have that information, that 15.9 stored. Okay, now the next command under my if statement, just to recall, okay, is so I completed this command now. Now I'm going to work on this command. Okay, and I'm going to, sorry. Okay, so I'm going to take 15.9. Okay, and then since that's the innermost function call, okay, I'm going to transfer control or pass control, okay, to the function at this point. So we're going to leave the main and we're going to move into this convert to Fahrenheit function. Okay, at this point, 15.9 comes in here and it gets a new name. Okay, so the parameter is passed in. Over here, it was called input temp. Okay, out here, it's called Celsius temp in the function, and that's perfectly fine. Okay, so you can think of it as making a copy of that 15.9 value into a different variable. Okay, then the mathematics happens. Okay, so it takes this 15.9, multiplies it by 9, divides by 5. Okay, I'm going left to right to break ties here. Okay, then it's taking that whole answer and adding 32. Okay, that value happens to be 60.62. Okay, and then that response, that answer, is returned back to the calling function. Okay, so again, anytime I call a function, so here when I call a function, in here where I return something from a function, I'm passing data between the actual program, the main program, and the function. Functions within themselves can also call other functions. Okay, so when this comes back, okay, after the function call, that value 60.62 replaces this entire expression. Okay, so the print statement now looks like print, the corresponding Fahrenheit value is comma 60.62. Okay, this function gets replaced with its return value. I'm just fixing the quotes again. Okay, and then the outermost thing happens, okay, which is the print statement, which actually prints the value to the screen. Okay, so two simple little lines of code here with a lot going on inside them. Okay, so now we're going to do a, live example. We're going to write a function to compute the volume of a cone. So I'm going to do this in the command line interface. You can use PyCharm or IDLE or any other IDE that you want. It doesn't really matter, but I'm going to use the command line just because. Okay, so when you think about our programmatic approach to problem solving, okay, we first need to think of the inputs and outputs, make sure we can do it manually, write down the steps, convert those steps to code, and then test the program. Okay, so the first step is, I'm going to put these in comments. Step 1 is get the radius and height. I need those in order to be able to figure out the volume. Okay, so that's what the R and the H here is. That's the input. Okay, the output, okay, is, step I don't know what at this point, but it's going to be print the volume of the cone. That's our output. Okay, sorry, it's wrapping a little bit here. Okay, if I had a radius of 5 and a height of 3, okay, I could easily figure this out. So pi 3.14 times r squared is 25 times 3 divided by 3, which is 1. So I would have, 3.14 times 25, and that would be the volume. So I can make sure I'm mentally getting my answer manually. Okay, and then now we're going to convert those steps into code. Okay, so step 2 is going to be call a function to compute the volume. Okay, inside the function, step 3, inside the function, use the equation. And step 4, return the answer from the function. And then it looks like step 5 is actually print out the answer here. Okay, so this is our algorithm, figuring out the steps, our pseudocode. Okay, so now we're going to write the actual code. Okay, so I'm going to need a function. I'm going to call that function return volume or cone volume. It's going to take two parameters, radius and height. Notice that in Python, I don't need to give it a data type because Python is a dynamically typed language. Let me save as here. Whoa, I don't know what that happened. I'm just going to put this on my in my home directory. Program. Oops, shoot, sorry. Sorry, I want to save it as a .py extension. When I do that, my editor now recognizes that I'm using Python code, so I get the nice, pretty formatting here. Okay, I'm going to actually add in my documentation here. Compute volume of code. Inputs, or well, I guess I call it parameters usually. Radius and height as floats. So I don't care if there's decimal values in there. Returns cone volume as a float. And again, that side effects are continue to be none for right now. And it will be none for quite a while. Okay, so now that I'm in my function, I'm going to do a couple things. I'm actually going to import math. Okay, Python has a lot of libraries in it, so the math library is one that's really useful because it will give you values like pi. Okay, you don't actually have to use these, but it's a good idea if you are aware that they exist. Okay, so I'm going to do the equation, which is pi times radius squared, so times height divided by 3. Okay, so let me put some parentheses around it. I don't really need the parentheses, but it's always nice to do that. Exponentiation would happen first under normal circumstances, and then multiplication and division left to right. Let me just double check here. The Python math library. Okay, so if I look at the math library and I see my different options here, I can do remainders, I can do all kinds of stuff. I can do arithmetic functions and constants, which is what I was looking for. So there's a constant for pi, for e, and for a few other things. So it's actually math.pi that way. Once I have calculated my volume, I'm going to return that from the function. Okay, and that's the full function. So now I'm going to write the main part of my program. And I need to get the radius and height. So I'll call this r equals input. Well, I want it to be a float. So enter radius. This will prompt the user for a radius. I still always want to put a semicolon at the end, but I'm going to not. Same thing there. And then I'm going to pass these parameters into a function showing the volume. Okay, so I don't have to have the same variable names in my main that I have in my function. Okay, the program really could care less because it's creating new variables here anyway. Okay, so I'm going to save this and open up a terminal window. And we'll see if I had any errors. I often do, truthfully. So to run the program, I'm going to run Python 3 coneprogram.py. Okay, it asks me for the radius and the height. Okay, and I get a volume back. So I'm going to try to be smart and double check that volume. Let me open a calculator here and say, okay, so 3.14 times radius squared times, that's the squaring of the radius, times the height divided by 3. Okay, and I get pretty much the same answer. The math.pi has more significant digits than the one I used when I just used 3.14. Okay, so that is our quick function example using our program development or algorithm development process as well.